Hi, in this video I will explain how transport, utility and business disruption are calculated within the INDRA model. But for more information, please consult the Deliverable 2.3 Coastal Risk Assessment Framework guidance document available on the RISC-KIt website. To calculate these three indicators, it is first necessary to assess the direct impact to the assets. However, this will not be covered in this video. You will need to look at the video on direct impact assessment. What we are trying to assess here is the propagation of the direct impact through the system beyond the hazard area. In order to assess the potential interruption and disruption of services through the whole network. To do that, we have to take a systemic approach. That means we have to consider the different nodes and links within the networks and their associated function of production, flows and capacity, as well as their relative importance. We also need to understand the network's topology to better assess the existence of dependency and interdependency within the networks, the degrees of uniqueness, and the potential substitution. You can use different modeling techniques to assess the impact on networks. You can use empirical analyses which are based on survey and expert inputs. You can use statistical analysis, network analysis, or even more complex modeling techniques such as flow modeling or agent-based modeling. For INDRA, the network analysis was preferred as faster and less data demanding, and as such, the technique was answering the best the constraints of the assessment. The technique analyzes the network structural property based on node and link characteristic and generate indicators such as the connectivity between two nodes or the centrality of a node in a network. In INDRA, the network is represented by nodes and link using polyline shapefiles. For any type of network you will have to analyze in INDRA, you have to define your network using a 5-step approach described in the Coastal Vulnerability Library. The 5-step approach consists in first approaching stakeholders, trying to understand the importance of the system and collecting data. Then you will have to produce a table listing the key components of your network and produce a schematic of it. Then you will have to map the schematic diagram to understand which components are potentially exposed to the coastal event. Then it is also important to develop a narrative to try to describe the vulnerability of the system and its potential consequences before actually running the INDRA model. For the direct impact assessment and in terms of recovery time, you will have to define this information within the CHT for INDRA text, as again described in the video on direct impact assessment. For transport services, the model indicates the potential degree of transport disruption by considering the loss of accessibility between places or the increased travel time between these places. The importance of the places are also necessary to consider to weight the potential disruption. So, to do this calculation, it is necessary for you to collect information on the transport network, for instance, and the relative importance of the different locations. The model will then calculate the loss of accessibility by calculating a connectivity ratio and the increased travel time by calculating a travel time ratio, and will combine these two indicators into a weighted disconnection and time lengthening indicators. This indicator is calculated on a daily basis and integrated over the maximum simulation time. For utilities, the model indicates the potential level of service losses by considering the disconnection and the imbalance between supply and demand nodes. So to do that, you will have to identify the schematic of the utility network and the geographic location of the exposed assets. The demand node, for simplicity, is represented by the last distribution asset of a network and not by the individual properties. You will also have to find information of the asset's vulnerability that will be inputted into the CHT for INDRA text file. And you need to assess the demand and supply quantity. You should use a similar unit for a selected network. That could be for water supply, for instance, the volume of water per day or the equivalent inhabitant. Now, in terms of representation of the network geographically, it is important that in the exposed area, every asset and there are specifically located, as well as the link between the nodes. For the other assets, some are within the regional demand and they need to be represented, but their geographic location is not pertinent. You also need to represent assets that are situated outside the regional analytic boundary. Again, their geographic location is less important. So the analysis will then estimate the connectivity loss and the imbalance potential and combine them into one indicator. This indicator will be calculated on a daily basis within the model and will be integrated over the maximum simulation time. For the business supply chain, the model indicates the potential degree of disruption of businesses by considering the loss of supply for every tier of a considered supply chain. To do so, you need to identify what is the most relevant economic activity impacted in your area and the supply chains that are associated with this economic activity. It is also important to understand the importance of these different tiers and their relative proportion in the exposed location. So for that, the businesses need to be precisely geographically defined in the exposed area, but they also need to be represented outside the exposed area. But there, their location is less important. The network analysis consists of assessing the change in the supply capacity of every node of your supply chain. This indicator is calculating daily during the simulation and integrated over time. As for the other network disruption indicators, the value is calculated between 0 and 1, 0 indicative of no impact